One of the posts that attracted me to your LinkedIn profile was that assumptions of causal inference, right? Can you explain the key assumptions of causal inference? Those are exchangeability, positivity, consistency, no version of treatment, and no interference. I believe the last three can be clubbed together as satwa. But yeah,
Mhm.
please go ahead. Yeah.
Yeah, absolutely. Yeah. So exchangeability. So in epidemiology, we talk a lot about confounders. And sometimes the term is used, the same thing is meant, but different terms are used by different fields. So a confounder in our field is a variable that causes both the exposure and the outcome. There's a little bit of nuance that there can be confounding, which is basically association can go from the outcome to the exposure variable through a pathway. What we want to do is we want to make sure that that's not possible. Because what can happen is you can have these spurious correlations. So it looks like there's an effect or it looks like there's no effect when there really is. So exchangeability is making sure that the groups that you're blocking that pathway, so you're blocking that flow the um, from the outcome to the exposure. In an RCT, that's done through randomizing. So the best example is through an RCT. And when you randomize patients, there is nothing that causes someone to get the treatment. It's random. So you don't have to worry about that. In observational data, you can use like an outcome model. So you're modeling what the outcome is to adjust for that. You can model the exposure to account for that. So it's to make sure that those groups are exchangeable for those confounders. So it doesn't matter if there's, well, it can matter for other reasons, but the assumption to be met, it doesn't matter if there's more, um, say looking at whether monsters enjoy coffee. There can be a different kind of monster if it's not a confounder in one group versus the other, and that won't have as much of an effect. It's really for confounders. The second one is positivity. So positivity, again, in an RCT, it's inherently met because everybody that is in the trial, in order to be randomized, you have a chance, a less than zero chance of getting treatment. Otherwise, it wouldn't be random. You'd know what it was. So positivity is something that needs to be checked with observational data. So when you're fitting a model, you want to make sure that people can have a probability between 0 and 1 of receiving treatment. It's really greater than 0. That's the problem, because you know that somebody can't receive treatment. That's positivity. Consistency is a little bit of a tricky one, or at least I found it was. It has to do with if the person actually receives treatment, then their observed outcome is their potential outcome under that treatment. So it's basically linking the data that you have to that treatment. So the reason that consistency, no version of treatment, and interference are all tied together is because it has to do with you defining your treatment. So that kind of leads into the no versions of treatment. If we say, does coffee cause happiness? Or coffee maybe is a bad example. If we say, do hot beverages cause happiness? Are we talking about tea? Are we talking about hot water? Are we talking about coffee? About I don't know why, but like a hot
Chocolate.
smoothie? Yeah,
Yeah.
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 Yeah, chocolate. Yeah, thank you. Good example. So you want to be very clear in what exactly you mean. And that's why often in clinical trials, they'll be as you want to leave as little ambiguity as possible. So it'll say like this is the dose for this duration in for these patients to make sure there's no versions. Because if you say, okay, hot beverages do cause happiness, but does coffee, does tea? Um, so that's where it kind of blends together. And the no interference. This one is that a patient's treatment status can't be affected by another treatments. So this isn't met when you have things like vaccine studies, or not vaccine studies, but when you're looking at exposure to different diseases. So, for example, COVID was a big one. You can transmit that to somebody, so that assumption wouldn't be met. And there's methods that are different that can account for that. But typically for the work that I do, that's never really a problem.
Great.